In C#, we can have multiple methods with the same name but different parameters in the same class. This is called method overloading. By changing the parameters of a method, we can create different versions of that method name. This allows us to reuse the same method name while keeping each version unique depending on what we pass into it as parameters. Here, the key rule is that methods must differ in parameter types, order, or number. Hello guys, welcome again. In the optional parameter lecture, we showed a method that adds 2 or 3 numbers together. To call the method with 2 arguments, we made the third parameter optional. As we said, when we call the method with only 2 numbers, the third parameter is not ignored by the compiler. Instead, it uses the default value we set for the optional parameter in the method signature. Method overloading allows us to do something similar. We can call a method with different numbers of parameters. For example, here we have one method that adds 2 int together and another method that adds 3 int together. But with method overloading, when we call the sum method with only 2 arguments, the third parameter is completely ignored since the number of parameters is different between the methods. As long as the method parameters are not the same in types, order, and number, we can create as many methods as we want. This allows flexibility in how many arguments we can pass to a method without needing optional parameters. Okay. In this example, we're overloading the sum method by having different versions with a varying number of parameters. We can also overload a method by changing the data type of the parameters. For the sum method, we could create 4 more overloads by changing the parameter types to double or decimal. This allows us to call the sum method with different data types, like int, double, or decimal. In this case, the key thing is that at least one thing must be different between method declarations, whether that's the number of parameters or their data types. Okay, method overloading can be done by changing the order of parameters as well. We can define multiple methods with the same name, same number of parameters that are the same type, but in a different order. In this example, there are 2 display methods. One where the name comes first, and another where the order ID comes first. Based on the order, we pass arguments in the method call. It will invoke the matching version. If we want to display the customer name first, we call the first display method. To display the order ID first instead, we call the second display method version. Alright. Based on what we discussed, there are 3 key rules for using method overloading in C#. Rule 1. Methods must have the same name. For example, here, all our methods are named sum. Rule 2. The parameters must differ in number, type, or order. Here, the sum methods vary in the number and type of parameters. And the display methods have the same number and type but different order. Rule 3. The return type can be different, but is not considered for overloading. If 2 methods only differed on return type, it would cause an error. Okay, as long as these rules are followed, C# allows method overloading. Alright, let's open up the VS Code to see method overloading in action. Here, we have a class called AreaCalculator. Now, let's define some methods. The first calculateArea method takes a double for a radius and calculates the area of a circle. When called with one argument, it treats it as a radius, so it calculates the circle area and returns it. The second calculateArea is overloaded to take two doubles for length and width to calculate a rectangle area. In the main method, we call calculateArea once with one argument for a circle and once with two arguments for a rectangle. Now let's print their results. Then run the application. Okay, we see the expected results. It calculates the correct area based on the number of arguments. Now let's define another version of the calculateArea method. This time it takes 3 parameters. This calculates triangle area using Heron's formula. Okay, calling it with 3 arguments. And then print the result. Let's run the application once more. As you can see, everything works fine. By overloading in this way, we encapsulate different shape area logic in a single well-named method. Also, we can create other versions of this method with different data types. As you can see, method overloading allows seamless method calls, while distinguishing implementations based on parameters. All shapes reuse calculateArea, but have unique calculation logic. This demonstrates how overloading empowers code reuse and separation of concerns through parameters. Okay, done. See you soon.